Hi guys. Okay, so this is the last thing that we're going to be really discussing in this unit about parabolas, and we're going to be talking about translations of parabolas. So let's just talk quickly about what a translation means. So a translation is when you move a shape a certain distance without changing it in any way. So you hear about that a lot, like in geometry with shapes, and they ask you to translate a shape. They just ask you to move it, shift it up, or shift it down. So again, when the parabola shifts, it means it's going to move vertically, meaning up or down, or horizontally, across, left or right, or it's going to move both. So let's talk about that for a minute, because in order for us to understand how to shift or translate our parabola, we need to understand what a quadratic parent function is. A parent function. Just think about it like this. Whenever you have a parent, the children are going to take a form of that parent. So this is our parent function. Y equals x squared. That is really important. You need to write that down, that this is always our parent function, meaning every parabola is going to start from this place. So in other words, all other parabolas are just a version of this one. So they might be fatter, skinnier, they might be stretched out more, they might be upside down, but they're still going to take a form of this function. So let's kind of think about that function and what it means. Okay, so if we look here, it says, I'm asking you, well, what does the parent look like? So again, we have y equals x squared. So I just want us to just think about it for a minute, even though I actually think that you already understand this, but let's just break this down. So let's make a table. Remember, a function. If you put something in for x, you're going to get an answer for y. Remember, that's what a function means. So let's just start with some basic numbers that you see most people start with when they're graphing. We'll just do -2, -1, 0, 1, and 2. You'll see that table a lot. Okay, so again, if you plug in -2 for x, you're going to get 4. If you plug in -1, you'll get 1. If you plug in 0, you'll get 0. If you plug in 1, you get 1. 2, you get 4. And 3, you get 9. I'm not going through that quickly because I think that you can pause the video and just kind of try that yourselves to make sure that you understand how this table looks like this. But basically, again, whatever you put in for x, you're going to get your y. That's a function. So let's take a look at our parent function to make sure that we understand what that looks like. So this is very, very simple. So we're going to look at our table. So if we plugged in our -2, all right, for our x, we're going to go up to 4. If we're looking at our -1, we're going to go up to 1. If we're at 0, we're going to be at 0. And if we're at 1, we're going to go up to 1, right? 2, we're going up to 4. And 3, we're going up to 9. And on the same side, we could put -3 over here, and we can go up to 9 because -3 squared is 9. And so that's our parent function. So then we just make sure we put our we make our u our parabola. And so that's our basic parent function. But doesn't that look the same as I taught you before with the strategy about the 1, 3, 5, and 7 strategy? It's the same thing. Because now for y equals x squared, our vertex is going to be 0, 0. That's what your vertex is. There's nothing there. It's not going up. It's not doing anything. It's just 0, 0. So we're going to start at 0. We're going to go over 1, up 1, over 1, up 3, over 1, up 5, and we're going to do the same thing. And if you notice, we're doing the same thing on this side. So we already learned the parent function. I'm just giving you a name for it. So now when we're graphing a parabola now and we're translating a parabola, all we're going to do now is we're just going to shift our parabola either left or right, or we're going to shift it up or down. Okay, so let's kind of think about that for a second. Let's go back and look at our vertex formula. We remember that a times x minus h squared plus k is our vertex formula. And we know that, remember, our vertex is going to be h comma k. Remember, you flip this. So whatever this is, you flip it and you get your vertex, right? So let's just think about that. Let me give you an example of a problem that you're going to have to translate. So let's say we had y equals negative x minus 3 squared plus 2. Okay? So we are going to the first thing that you're going to do is you're going to identify your a, your h, and your k. Okay? So instead of locating a, b, c, remember we're talking about vertex formula now, so we're going to do our a, h, and k. So our a equals negative 1. Our h equals 3 because we're flipping this, right? Our k equals 2. Okay? So this is not as hard as you think. So what we're going to do is we're going to go back to our graph and we're going to graph this. So remember your parent function, right? So let's go back to our graph and we're going to look at our parent function. So all we're going to do with this parabola is we are going to shift it, and we're going to talk about how we're going to shift this. So let's look carefully at this equation. So we have negative 1, we have h is 3, and we have k is 2. So let me show you something. Your h is representing your horizontal shift. Remember h for horizontal, meaning you're going to go either left or right. And your k is going to represent your vertical shift. Remember k for kite, because if you fly a kite, you have to go up with the kite, right? Okay, so again, your h is horizontal shift, k is your vertical shift for kite. Okay, so let's look back at our equation that we have right here. And we have y equals negative x minus 3 squared plus k. So in this case, our vertex is 3 and then 2. So we flipped, that was our h and our k, so 3 and 2. So all I want you to do is come back over to our graph and we're just going to locate our vertex. So here's 3 and we're going up 2, correct? Now, remember, this is a negative 1 for our a. So what do we remember about a negative a? We remember that it's going downwards, right? So our function is going to look exactly the same. Our graph is going to look exactly the same as our parent function, only we just translated it. We moved it over to 3, 2. So we actually moved it to the right 3. So we were at 0, 0. Our parent function's at 0, 0. But with our vertex, we just moved it over to 3, right? And we moved it up to our k value. We moved it up 2. So our point went from 0, 0, and we moved it over 3. So 1, 2, 3, and we moved it up 2. That's all we did. We just translated it. Now all we're going to do is we're going to recreate our same exact graph. But this time, our step pattern is going to be, so let's go back to our step pattern. Our step pattern is going to be negative 1, negative 3, negative 5, negative 7. Remember? Because our a is negative. So let's go back here. Let's go back to our vertex. That's our vertex. 3, 2 is our vertex, right? So now we're going to go over 1, down 1. Over 1, down 1. Now we're going over 1, down 3. Over 1, 1, 2, 3. Over 1, 1, 2, 3. Then we're going to go over 1, down 5. 1, 2, 3, 4, 5. Over 1, down 5. 1, 2, 3, 4, 5. Well, there we go. We have enough points to go ahead and draw our function. our parabola, our new parabola. And so if you notice, all we did was we shifted our parabola over 3 up 2. And that's it. We just kept the same exact parent. It looks exactly like our parent function. It's just translated over 3 up 2. And so that should help you a lot. I hope that made sense. And I'll come back with more examples tomorrow.